For this project, we have a ring. It kind of has a soft curve that comes up and holds in this half bezel. So the shank meets up with the half bezel. There is a spot right here where it's not connected quite right. We're going to talk about that later on. And in the model, you can see we've got the shank, the head, and all the curves that were used to create the model. So I always hold on to those creation curves in case they're needed later on to make a change. Now, one thing that's important to check on is to make sure that you have a ring rail in your model. If it's a ring model, you need to have a ring rail. Now, to mill this, we want to go ahead and enter into the Millworks, the builder, Millworks C, okay? And follow the instructions in the upper left-hand corner. It's asking us to put the model in the box, okay? So what you want to do is you want to select the entire model, and all I'm doing is coming over here, clicking and holding down on the button, on the left mouse button, and dragging a box around the model. And you can see it's all highlighted pink right now. Well, that means it's selected. So with it selected, come over to the model window and click the arrow underneath the model window. That's going to place the entire model into the model window. The instructions are going to prompt, I think you're making a ring. If this is correct, select the support setup. Otherwise, click on non-ring model. Okay. So it's seen that we're making a ring because we've included the ring rail in the model. Okay, it's important. Okay, that's important. And the reason why is because including a ring rail in the model automates supporting the model, okay, with these little blocks out here. So we want to choose a strategy to mill this project out. The first strategy here comes down from the top and then in from both sides. Well, you can see that from the top down, there's no detail here that you couldn't just get from the side. Okay, if we zoom in, there's no hole down here that needs to be milled. Okay, and because there's no undercut here, this is all a solid piece of material, we should be able to approach this model from this side, basically from what you see in the through finger viewport, and then from the opposite side. So this image here should complete the entire model. Okay, it's not saying you couldn't use this strategy. You could approach it from the top and then in from both sides. That's just one extra step to mill, which is going to add additional milling time. Whereas this strategy here just mills in from two sides, eliminating the third side or eliminating that extra mill time. Again, you could use this strategy here, the base clamp strategy, where it mills in from the top and then in from four sides. There's no harm there except the milling time. Each time you approach the project, it's going to add additional milling time. Now the three-jaw chuck strategy, remember your cutter is shaped with a diagonal. So you couldn't successfully mill your project with this strategy because, let's see if I can explain this. Because you can see if it was milling up and across here with the three-jaw chuck, you would not get this undercut here. Okay? Okay. Another thing to think about here is this little section that does not meet up with the shank perfectly. If we approach it only from this side, the mill will never see that this is an open surface. It's only going to see what you see in the through finger viewport. So it's going to ignore that this object is not solid. Okay? It does not care at all that this is not a solid object. So, and the mill will never see that open area because the tool will only approach from this side in 180 degrees. Okay. So for time purposes, learning purposes, we're going to choose this strategy here. And when we choose this strategy, it automatically builds supports for you. The supports are generated automatically based on the ring rail. Okay, if we hide this, we look, the supports are going to be automatically offset from the ring rail 1.5 millimeters. Okay, so it's automatically going to put in 4 supports that are offset from the ring rail 1.5 millimeters. Now, underneath the support setup, where we've chosen the dual fixture, we need to choose the center type. Let's talk about a couple of these. The first center type with this red no sign, okay, what that's saying is it's going to mill the project with what's called a raster path. What a raster path does, let's hide this one. Okay, if this is our cutter would come in and then it's going to mill back and forth, back and forth. Okay, all the way across the inside finger hole. Okay, if we chose this strategy. That takes a little bit additional time as opposed to the second strategy. If we chose this strategy, what's going to happen is the tool's going to come in it's going to approach the model near the ring rail and it's going to do a quick little round cut, removing all of the wax on the inside. Okay, then the fixture will flip 180 degrees. It'll make this cut again on the opposite side, allowing you to remove the inside plug from the finger rail. Then when the actual cutter approaches the model, it's going to come across and back. And when it gets to here, it'll start down one side and then across the bottom and then up the other side. Okay, so it just eliminates a little bit of milling time to choose the cutout center. Okay. The next strategy, cutout strategy, is to use the Dremel tool or the disc cutter to come in and hollow the inside of the ring out. Okay, well, you can see that this is solid underneath. So there's no real reason to use the Dremel cutter. So this would not be a good option for us. And the last strategy we'll talk about later in this video series. Okay, so for the time being, we're going to choose the second strategy, the cutout center. Now that we've chosen the support setup and the cutout center, it's time to take a peek at our supports. And it's a good thing we did. If you look here, you can see there's space in between the shank of the ring and the support. So we need to make an adjustment on these supports. We'll just drag that support in towards the model, making sure that it's touching. So that as it mills out, you can see it in this picture, it doesn't just fall out of the block of wax. It's held there by the support structure. Okay, also the one at the top, or I'm sorry, the bottom one. Then the one at the top can go away completely. So we're just going to hit the delete key on that and have it support it from 3 sides. Now, the trick to the supports is you can do some manipulating with these. You could scale them. You could move them up and down. Like say you wanted to support it higher up, well, you can see it's not really touching the shank, so we'd need to move it this direction too. You can get away with that type of manipulation of the support. What you don't want to do is you never want to take a support from this side and put it over on this side. Okay, the supports always need to stay on the side that they were created. Okay, and in the general area that they were created in. All right, so now that we've verified that our supports are touching the model, we can go ahead and proceed. You can see that as soon as we chose the center type, a green block appeared on screen. This green block is telling us what size wax it's suggesting that we use. Okay. In the event I make some type of change, it takes my supports away and puts them back again. So I would need to come in and verify that it was actually touching the model again. Okay. Because it's always going to put them in their default location. So that's something to just be aware of. Okay, so we're going to go ahead and click next. And this page, if you didn't have a 10 millimeter block of wax, you just want to make sure you're selecting the wax type that you have in stock and make sure it matches what you're selecting here on the computer screen. So it's suggesting a 46 by 42 by 10 millimeter piece of wax, which I have. So I'm going to go ahead and leave it at what it's picked for us and click the next button. So you can read the instructions, select the wax size, click next to continue. So we've done that. Select the cutting angles option and click next to continue. Okay. For a two-sided flip, all it's going to do is come in from one direction, flip 180 degrees, and come in from the other direction. So that's our only option. Click next. And on this page, it says select the cutters and distance between toolpath options. Click make paths to create toolpaths or click next for detailed options. So I'm going to go ahead, I'm going to use the 10-degree cutter, and I'm going to go ahead and click the make paths button. We'll just pause the video for a moment. Okay, now it's always a good idea to look at your toolpaths. So if you can make sense of it here, that's fine. Sometimes what I like to do is I like to go to the next page, which is the detailed options section, and look through each step of the path. To do that, to look through each step of the path, it says click on icon below to view and edit each part of the job. Make paths to create tool paths. Clicking back will delete any changes. So we want to make sure that we stay in this section, and part 1, if I click on part 1, it's going to show me cut out center. That's this red cut that comes in and cuts out the finger hole. Okay, and it does it on one side, then it flips over and it does it on the other side. The next section is the flat on dual 3 sides. Well, it's very, very difficult to analyze these tool paths when they're overlapping. So if you double click on part 2, it will expand it into subpart 1 and subpart 2, allowing you to click on each individual path and view it, making sure that it looks proper. And we can see that the mill's coming in. It's hovering on the geometry. Okay, it's coming around. And right when it gets to here, it's not milling deep enough to complete this uh, entire shank. So we need to adjust the mill depth. Okay. Whenever the tool paths are created, what happens is the depth it defaults the depth to 1 millimeter past the construction plane. So if that's not deep enough in your project, you need to go in and change that. The way we want to do that is we want to double click on subpart 1, and we have all of the aspects of the tool paths that we can control. The part that we want to control is the cut depth. When I click on cut depth, it brings out my mill depth, my plane, with a cutter showing me that it's defaulting at 1 millimeter past the construction plane. And it tells us, click go to rotate and or move the cutting plane to the required position. Press enter to finish. So we're going to click go, which is going to allow a viewport control handle. If I zoom in, when I hover over it and it turns red, click and hold and drag this down to where it's deep enough to cut all of the detail on this shank, on this side of the shank. Once I'm done with that, I need to press the enter key and my viewport control handles will go away and that change has been made. So we've done that for side 1 or subpart 1. We need to do the same thing for subpart 2. So either double click, yeah, it's a double click, or you can hit the little button here to expand the options underneath subpart 2. And again, here, I knew it was going to be the same because it always defaults to 1 millimeter past the construction plane. So we simply need to do the same thing for the other side. Click on cut depth, click go, use your viewport control handle to make your adjustment, and press the enter key. Now if we hit make paths again, it's going to recreate the tool path with our new settings. Okay, now that the new tool paths are processed, let's go ahead and take a peek at those. Subpart 1. Now subpart 1 is going down, completely milling the shank there. Okay. And subpart 2 comes in from the other side, milling it completely out. Okay, so that's what you want to see. And this example was chosen specifically forcing us to make some depth changes so that you would be aware and always look at your tool paths, making sure that it's going to complete your model. That is how you process a dual fixture part. Okay. The last but not least, you'd want to save this tool path. So we just want to click the save path button. Just going to bring up a choose output file. And we will name this, not really a bypass, but call it a bypass. I like to include the name of the file and then the name of the cutter that I'm using to mill it. And the reason that I include the cutter definition in the title is because I can quickly look at a list of files. Say I have 5 files to run. Well, I know I want to use the 10 degree by glance. So I can eliminate the amount of cutter changes I do during the day by just glancing at the title. Well, I'll run all 4 of the 10 degree cutter ones first, and then I'll run a 15 degree cutter one next. So any information you can supply yourself will help in later when you're actually milling the project. and then we'll just simply click the Save button. From here, if you refer to the transferring a file to the thumb drive section, you can see how to put your file on the thumb drive and get it to your mill computer. Okay.